Hi everybody. On this video, let's take a look at solving a system of equations with three unknowns. And if this is one of my classes, typically on my tests, or if it's on the final exam, that's a multiple choice final, typically they have you solve for the z variable or the y variable or the x variable, but they won't show all three options for x, y, and z because they know it's just too tempting for you to back substitute to try to find your answer. So if you're thinking of back substituting on one of my tests or on the final, think again. All right, so on this one we're going to solve for z. So what we're going to do is we're going to combine the first and second equation here. Before I go there, notice this is a little different than other systems of three equations with three unknowns that you may have seen before, particularly in that the first equation has two variables. The third equation also has two variables, different variables, but they have two variables all the same. And the second one has three variables. You would think this would make it harder, but actually this is going to make the problem a little easier, as we're going to find out. So go ahead and do cartwheels if you see one of your original equations only having two variables in it. Anyway, we'll combine the first and second equations together, and by doing so, we're going to have to eliminate y. The reason I'm eliminating y is because look at the third equation. See how it only has x and z in it? When I combine equations 1 and 2, I have to get rid of the y variable. That way I can end up with another equation with x and z in it. Because if I tried to get rid of, say, the x instead of the y, then my resulting equation would have had any variables y and z in it, whereas this equation has x and z in it, and I've really kind of put myself in a corner. You want to make sure you have as many unknowns as you have equations. That's kind of your general rule of thumb here. So we will multiply the first equation through by a -3, and the second equation we'll multiply through by a 2. What we're after are these additive inverses of -6's, all right? -3 multiplied to the x plus 2y equals 6 will give us -3x minus 6y equals -18. As for multiplying the 2 to the second equation, that'll give us 14x plus 6y plus 2z equals -66. Now that we have our additive inverses, we can add the two equations together. -3x plus 14x is 11x. The y term drops, that's what we wanted to happen. I still have this 2z here. As for the constants, -18 plus a -66 is a -84. Now let's combine this new equation, this guy here, with the third equation, the x minus z equals 16. And we're going to eliminate x in the process because we're trying to solve for z, right? So this should be familiar territory. You should have already covered elimination with two variables. We'll take the first equation, we'll multiply it through by a -11, right? That'll give us a -x plus 11z equals a -176 when you multiply the -11 times the 16 there. All right? So when we add these two equations together, the x term drops out. 11z plus 2z is 13z. -176 plus a -84 gives us a -260. Dividing both sides by 13 gives us a z value of 20.